Okay, Assalamualaikum and very good evening again to all of you. Okay, so we are in week 12 right now, less than a month before your final exam. So this will be our last chapter, as I've mentioned last week. So this will be our last chapter concerning the environment, energy and environment. Okay, and basically, this chapter won't be too long, especially since it's about environment. Is more actually you can just read the theory part. Okay, so I'm just going to introduction. Okay, maybe summarize about uh, the air pollution, etc., concerning the renewable energy. Okay, the impact of the renewable energy towards the environment. Okay, and then we will see some example, and maybe we can finish just by Maghrib, so that we don't have to continue after Maghrib. Okay, so we start. Okay, so basically, we have our atmosphere contain about 78% of nitrogen. So this is the composition. I think by now you know this composition, the roughly composition of molecules in our atmosphere. 78% of nitrogen, 21% of oxygen, and about 1% of other gas such as argon, carbon dioxide, etc. Okay, so basically, our atmosphere, okay, is being pulled by the gravitational force. Thus, it gets less dense with increasing distance from the Earth. So the atmosphere, the air, far away from the Earth, we have a less density. Okay, so this is our level, different level of atmosphere. We have troposphere until around 10 kilometer above the earth, and then we have what we call stratosphere, around 10 to 50 kilometer above the earth, and then mesosphere, and lastly is the thermosphere. Okay, until around extends to about 300 kilometer above the earth. Okay, so the air circulates vertically and horizontally. Okay, so that's how we have the combination of the air movement, the velocity, speed, etc. This creates the winds, the weather patterns in around the world. Okay, so okay, now the pollution. Okay, that we want to more concentrate on the pollution of the atmosphere. So what caused this pollution? Okay, so pollution is any addition of matter that degrades the environment. Okay, degrades down the environments, our environment, and will cause negative effect to human health, human being, and other organisms. Okay, so but all of this mainly due to our human actions, right? So how our actions cause make major cause of the pollution. Okay, so we have to do something to prevent, at least to reduce this air pollutions. Okay, so air pollution due to the automobile emissions, chemical odors, smoke, etc. Okay, so normally this air pollution related to the number of people. So basically in mega city, big cities, urbanized cities, we and dense concentration of people, we have more problems of this air pollution. Okay, it depends on the number, the density of the people, and the activities which are mostly involved, which is industrial. Okay, these activities release large quantities of pollution. Okay, byproduct is secondary products into our environment, so it will cause health problems also. Okay, so this is example in the US. Okay, so basically the mega cities, the big cities in the US develop poor air quality. Okay, more dense, more concentrated people. Okay, so there's a lot of automobile emissions and industrial pollution. Okay, so the cause of this pollution are open fires, motor vehicle, etc. Air pollution increase the death rate and lower the general health of the population. Okay. Okay, so we have different categories of air of these air pollutants. So the first one is the primary air pollutants. You will see this first. So there are 5 major types of materials consist of these primary air pollutants. They are carbon monoxide, CO, volatile organic compounds, or what we call, it consists of the hydrocarbon, carbon and hydrogen, particulate matter, sulfur dioxide, and oxides of nitrogen. Okay, so these are example of the major types of primary air pollutants. Okay, that we can found in our environment. And then we have secondary air pollutants. Okay, these secondary air pollutants are formed from the reaction of the primary just now, and the reaction of the primary pollutants with water or sunlight. So example of the secondary air pollutants is the ozone. Okay, ozone are the secondary air pollutant caused by the reaction of the primary. Okay, and then criteria air pollutants are those pollutants for which specific air quality standards have been set. So, example in the US, they have what they call EPA, Environment Protective Agency, something like that. So that they specify the quality, the minimum quality standards of these air pollutants. So, I mean the measurement, what is the minimum that we can allow. Okay, the minimum emissions of this gas air pollutant that the environment can be allowed. Okay. And okay, so this one, carbon monoxide. So carbon monoxide usually caused by the vehicles on the roads. Okay, so carbon monoxide is produced by the organic materials burned with insufficient oxygen. Where we have normally in the chemical process, chemical reaction, we call apa tu incomplete combustion. Okay, which is a normal not ideal case. Normally we have incomplete combustion. So due to this incomplete combustion, insufficient oxygen, so this results in production of carbon monoxide. Okay, so this carbon monoxide, 60%, around 60% comes from the vehicles driven on roads, and the remainder others comes from the power plants, leaves, etc. Okay, so this carbon monoxide is dangerous when it penetrates our hemoglobin. Okay, so it makes it's harder, less able to for us to carry oxygen. Okay, so it is most dangerous in enclosed space. Okay, other than that, second one, we have just now the primary air pollutant is the particulate matter. Okay, so what is particulate matter? Normally noted as PM, particulate matter. So particulate matter is a mixture of solid particles and liquid droplets. So mixture, the formation of the this solid particle, small solid particle, very very small, around micron meter or nanometer. Okay, the diameter of this matter. So these particles mix with the liquid droplets found in the air, and that's how this PM particulate matter become. Okay, so it consists of minute pieces of solid materials around less than 10 microns. This is the diameter, estimation of the diameter of the particle of the matter. Okay, and liquid droplets disperse into the atmosphere. So the EPA, the US Environment Protection Agency, something like that. Okay, it has set standards for particles smaller than 10 microns. Is noted as PM10, and 2.5 microns, PM2.5. Okay, so larger than 2.5 are primary pollutants, and smaller are mostly secondary pollutants. Okay, so that's how they they create a guideline, okay, of the and classify this particulate matter in terms of the its diameter, okay. So most communities in US now meet the standard set for PM10, but exceed the standard set for PM2.5. So there are some standards set by this agency, the Environment Protection Agency of the US. Okay, in order to reduce the this particulate matter in the air pollution. Okay, next we have sulfur dioxide. This is the third one. Okay, sulfur dioxide, primary air pollutants. So sulfur dioxide, SO2, is a compound of sulfur and oxygen, of course. So the chemical reaction of sulfur and oxygen produce this sulfur dioxide when from the fossil fuels. The reaction from the fossil fuels molecules which contain this sulfur. Okay, when the fossil fuels is burned and containing the sulfur, so it can produce the sulfur dioxide. Okay, for example, from the burning coal, pembakaran arang tu kan hasilkan sulfur dioxide. Okay, so today about 70% released into the atmosphere due to the coal burning power plants. Okay, and then we have also nitrogen dioxide, oxides of nitrogen, NOx, NOx. Okay, from the fossil fuels when they are burned, the combustion process of the fossil, mainly in power plant, of course. And then so this nitrogen dioxide are formed from the nitrogen and oxygen molecules in the air combined with one another, okay, when subjected to the high temperature, means during the combustion process. Okay, so we have two types, nitrogen monoxide and nitrogen dioxide. Okay, are the most common. Okay, so burning of the fossil fuel, for example, in the internal combustion engine, motor vehicles, is the main source of this production of nitrogen oxides. Okay. And okay, continue about 75% of the nitrogen produced by an automobile engine. Okay, it can be converted back into nitrogen, gas, and oxygen by the catalytic converter. So we have this kind of like what we call is catalytic converter that can help us to convert back in order to reduce the emission of the nitrogen dioxide. Okay, to convert back the NO into nitrogen gas and oxygen. And then the other one of the primary air pollutant is volatile organic compounds, or we call it as VOC. So these are organic compounds that can be readily evaporate and become pollutants in the air. For example, our apa tu macam nyamuk tempat nyamuk riset tu, because it is from organic material, organic molecules, and when it evaporate, when we spray the organic compounds, so it can become pollutants in the air. So they are composed primarily of carbon and hydrogen. So sometimes we also refer them as hydrocarbon. Okay, so source of VOC emissions include internal combustion engine and solvents. Okay, those are the primary source of this VOC. And the rest other primary air pollutants is what we call a hazardous air pollutants. Then from the dangerous chemical compounds. Okay, air toxics. Okay, so these also can cause serious serious health to negative effect to the people, especially to those they are more harmful to those who are always presents with this particular pollutants during their job or in the industry, etc. And then photochemical smoke. Okay, so this one is the example of a secondary air pollutants. Okay, so as I've mentioned just now, secondary air pollutants is the mixture, is when the primary air pollutants, carbon monoxide, nitrogen, sulfur, etc. just now, react with the water or air in the environment. Okay, so it produce these secondary air pollutants, which example of is the photochemical smoke, macam asap no. Okay, it's a mixture of pollutants. It forms when nitrogen dioxide and VOC, the organic compound just now, volatile organic compound in primary pollutants interact under the influence of sunlight. Okay, when there is a high temperature or a warm temperature, okay, means there is a heat source, and so these primary pollutants can interact with each other and produce this secondary air pollutants, which is what we call this photochemical smoke. Okay, so example ozone and PAN. Okay, so photochemical smoke, ozone, known as O3, is a molecule of three oxygen atoms bonded to one another. Okay, so so this one you know, smoke. Okay, so how this smoke forms, develops. Okay, it requires several ingredients, for example, nitrogen monoxide, etc., and sunlight and warm temperature. Okay, this heat source important to support the chemical reaction involved. Okay, so this photochemical smoke can it, are easier to form at warm temperature, means warm weather, or during summer. Okay, so smoke is more likely to be a problem in the summer with higher temperature and longer days. So we have extra sunlight. So when we if our atmosphere is exposed, or the cities, the big cities are exposed to a warm climates and lots of sunlight, they are more prone, high possibility to develop this photochemical smoke, this secondary air pollutants. Okay. And then acid deposition, hujan asid, kita biasa panggil hujan asid, acid rain. So acid deposition is the accumulation of potential acid forming particles on the surface. So this also is one form of air pollutants. Okay, and this acid cause result from natural cause, volcanoes, lightning, etc. Acid rain is a worldwide problem. So it cause effects on the structure, terhakis kan, contoh bangunan-bangunan tu. And then effects on the terrestrial ecosystems also. Okay, fail to reproduce and many others die, or effect on the organisms. And then also destruction, okay, tak apa sikit. Okay, motor vehicle emission, as we mentioned just now. So motor vehicles are the primary source of several important air pollutants, carbon monoxide, VOC, nitrogen oxide, ozone, etc. So we have to place a control measure, like the several initiative have been made, okay, to control these emissions, especially from the motor vehicles, to improve in order to improve significantly our air quality. Okay, the same as a particulate matter emissions, there are several standards measure, okay, for these emissions of particulate matter. Power plant emissions also, the emission, the air pollutants caused by the power plant industry, electric power plants, especially that contains particulates, sulfur dioxide and nitrogen oxides. Okay, so some of the particulate matters emission have been controlled with filters and other mechanical means. So those are the prevention that have been made to control this emission that due to the power plant in the industry. Okay, nitrogen oxide are produced wherever high temperature combustion, etc. Okay. And I think this is the last part, air pollution in the developing world. Okay, just now we only see in the US, but we can see here roughly the risk or the poor air quality condition mainly in the urban areas or in the big city, mega city, and the most developed country. Okay, we can see here mostly in the US, but this is for particulate matter, PM10. Okay, so US less than 20, and then around Europe, of course, a lot higher. China and India dekat kat sini lah. Okay, so so we have to balance, okay, between the economic development and development of industry and this air quality, air pollution in the atmosphere. Okay. Okay, one other part is the indoor air pollution. Okay, within homes and other buildings also can cause seriously pollution. Okay, and these pollutants are thought to have adverse effects on human health. So those are the negative effect due to this indoor air pollution towards human. Okay, so the source of indoor air pollutants, basically the most important one is smoking. Okay, due to smoke. Okay, and then weatherizing. Okay, weatherizing is a protecting the method of protecting a building to increase efficiency, slows air exchange, and tends to trap pollutants. Okay, it means that sometimes in order to increase energy efficiency of a building or a house or building, we create this weatherizing like a protective method to increase efficiency of the building. But however, somehow this approach will slow the air exchange, air movement within the house, within the building, and tends to trap the pollutants. Okay, so those are the consequence, okay, of this when we try to increase the energy efficiency of a building. Okay, movement to reduce indoor air pollution lag behind regulations governing outdoor air pollution. So that uh, the prevention, okay, to reduce the indoor air pollution is still behind the those that have been done towards outdoor air pollution. Okay, the EPA again, the Environment Protective Agency is conducting research to identify and rank the human health risks that result from exposure, okay, pollutants or mixture of multiple indoor pollutants. Okay, so summary, okay, like I said, only 20-30 minutes to summarize this chapter. Okay, summary, the atmosphere has a tremendous ability to disperse pollutants. So the main cause of the main major types of primary air pollutants are carbon monoxide due to the insufficient, incomplete combustion process. Okay, insufficient of oxygen, so we have this production of carbon monoxide. Okay, and then hydrocarbons, the volatile organic compound just now, a mixture of carbon and hydrogen. Particulate matter, particulate mixture of the solid particles, small solid particle in the air with liquid drops. Sulfur dioxide from the fossil fuels, the burning of the fossil fuels, the same as oxide of nitrogen. Okay, those are the primary air pollutants. Okay, and then we have also the secondary air pollutants due to the formation, the reaction between those primary air pollutants with the water and warm temperature sunlight. Okay, so acid air is caused by emissions of sulfur dioxide and oxides of nitrogen in the upper atmosphere. These compounds form acids that are washed from the air when it rains or snows or settle as particles on surface. Okay, and then chlorofluorocarbon CFC also lead to the destruction of ozone. Okay, ozone is one type of the secondary air pollution which result in increased amounts of ultraviolet light reaching Earth. Many commonly used materials release gas into closed space. Okay, this is for indoor air pollution. So indoor air pollution also a major problem. Okay, not only in the outdoor environment. So we also have problem with the indoor air pollution that we need to focus on, where they cause health problems, especially to us. The most important of these health problems are associated with smoking. Okay. Okay. So yeah. So that is the introduction and summarize of the air pollutants. Mainly what we are trying to concentrate here, air pollutants due to the renewable energy and the combustion process, power plant, etc. Okay, so we try to focus on that. Okay, of course there are a lot of other causes of pollution in our environment, but we are focusing only on the due to the energy part. Okay, so I have a few example here. So because how are we going to evaluate or predict the amount of the pollution due to the ash, carbon, etc. We need to some of them we need to recall back the chemical process, and then the molecule, the composition of the mass, composition of this molecule in the gas, in the environment, in the air. So in order to solve to predict those emission, we need to recall back our knowledge on the chemical process. Adalah sikit-sikit tapi tak complicated sangat lah, bukanlah apa proses yang susah sangat lah. Tapi nanti saya tunjuk Okay, so this is the first one. Okay, the first example of what is this? Okay, power plant. Okay, power plant using coal, arang batu. Okay, so consider a coal with the following composition on a mass basis. So we have 67%, around 67% of carbon, 5% of hydrogen, 9% of oxygen, 2% of nitrogen, 1.5% of sulfur, and 8.5% of ash. Okay, abu-abu semua tu. And 7% of other moisture. The heating value of the coal is 28,400 kilojoule per kilogram. Okay, heating value. This coal is consumed in a power plant at the rate of 2,000 kilogram per day. Okay, so every day, each day, this power plant use around 2,000 kilogram of coal. Okay, which consists of this coal consists of all of these molecules: carbon, hydrogen, oxygen, ash, etc. Okay, so 2,000 kilogram per day, banyak. The plant operates 65% of the time annually. So we estimate that the plant annually, each year, dalam masa setahun, 365 days, the power plant which use the coal, okay, as the source, operate 65% of the time. So nanti, so later on we calculate 65% tu equals to how many days in a year. So tak adalah setiap hari, 65% only. So here we are going to focus only on the emission of ash. Ash ni je Okay, so first one, determine the amount of ash entering the plant per year. Okay, so we know that the coal, all of the molecules in the coals are being used 2,000 kilogram per day, but the plant operates only 65% of the time. So 65%, 0.65 times 300, apa, 50 satu tahun, 365 kan, 365 days. So how many days? More than around 200 maybe, around 200 days that the power plant operated. Okay, so to around 200 days and multiply with 2,000 kilogram per day. So we have 40,000 more kilogram of coal being used per year. But that is the mass of the whole coal, combining all of these all of those molecules. So we want just to we want to determine just the amount of ash. So 8.5% of this total mass use of the coal in a year. Okay. Okay, sekejap kita ni. So simple je. This one. Okay. So the plant operates 65%. So we just want to know how many days it actually operates. So 0.65, 365 lah ya. So tengok berapa hari, should be around 200 kan, sebab macam lebih pada separuh hari tu. So if you calculate this, so you have 200 of the operating days of the power plant is 237 days per year in a year. So only 237 days lah. Okay. And then okay. And then 2,000 kilogram of coal, annual coal consumption. Okay, so per day, 2,000 kilogram coal is being used. So that is per day, satu hari. So kalau 237 hari, darablah kan berapa. Ni jumlah coal, semua coal lah, belum lagi yang ash tu. Okay, so 2,000 mass kilogram of coal is being used each day. So throughout the year, 237 days. Okay, so dalam 400,000 lah ya. 400,000. So 474,000 kilogram per year of the total coal use dalam masa 1 tahun. Ni coal coal total. So we want to just determine the amount of coal ash entering the plant. Okay, because the coal is consists 8.5% of ash. Okay, so ash, okay, in a year, so 8.5%, 0.085 multiply 474 ni lah. Okay, 474 so 1, 2, 3, so around 1, 2, 3, 4, 5, 6, 7. So we have around 40,000 kalau 0.1 47,000 so only 0.085, so 40,290 kilogram per year. Okay, so this is the amount of ash entering the plant, the power plant, or the amount of ash consumed per year. Okay. Okay. Next, determine the amount of ash entering the plant per megajoule of heat input to the plant. Okay. Just now, per year, so per year around 40,000 kilogram per year. This time, per heat input. Okay. So of course we need to calculate first the heat input. Okay, the heat input of the power plant. Okay, so basically in a power plant, the output desire is the electricity production or the mechanical power, right? So in order to produce this electricity or mechanical power from the power plant, we need to input an amount, some amount of heat, okay, which is normally the fuel, what we call fuel, heat input. Okay, so heat input to the plant. So in this power plant, the heat source or the fuel, when we say fuel here, it doesn't mean mesti minyak mesti macam diesel lah. Bila kata fuel ni bahasa dia term that we use for power plant or combustion engine, etc. When we said fuel means the heat source. Bukan bermaksud apa tu minyak ataupun diesel ke apa ke semata-mata lah. Fuel ni adalah the heat source untuk in order to generate the power plant lah. Okay, so here the fuel is the coal. Okay, coal. So coal is the input. Okay, the heat input to run the power plant. So we need to calculate the heat input of due to the coal. Okay, the heat input due to the coal. So just now we already have the amount of coal consumption per year. Okay, the amount of the coal consumption per year for 237 days. Okay, and we have here the heating value of the coal. Okay, the heating value of the coal is 28,400 kilojoule per kilogram. Okay, so for this one, we calculate first the heat input, and then later on we divide with the mass of the ash. Okay, so the heat input will be the mass of the coal per year used. The mass of the coal multiply with the heating value of the coal given. Okay, so the mass of the coal just now, this is the annual mass of the coal used. We already calculate it here. So 474,000 kilogram per year. So put it here. Okay, multiply with the heating value. Heating value is 28,400 kilojoule per kilogram. Okay, so we have the total heat input in kilojoule per year. Kilojoule per year. Or we can change it into megajoule directly. So in megajoule, it will become 1.35 10 power of 7. Okay, megajoule per year. Okay, so this is the mass of the coal is in kilogram per year, and this one is given in kilojoule per kilogram. So we have the answer in joule, megajoule per year. Okay, so but we're not finished yet. Determine the amount of ash entering the plant per megajoule of heat input to the plant. So we have this value of heat input in megajoule. So the amount of ash per megajoule, okay, is this one 40,290 divide by 1.35 tu lah. Okay, 1.35. So per heat input means that we are calculating the amount of ash consumed in the power plant for each heat input megajoule of coal. Okay, means that 1 megajoule of coal consume around, okay, if we divide here, we get 0.003, around 0.003 kilogram, or if we change it into gram, it become 3 gram lah. 3 gram ni sikit je. 3 gram or 0.003 kilogram per megajoule. Okay, 3 gram. So very small je lah. Okay, so 3 gram of ash is consumed per heat input of coal. Okay, so this is B just now. This is question A. Okay. Okay, if we look back at the question, C, if only 2% of the ash entering the plant is emitted to the atmosphere with combustion gas, okay, determine the mass of ash emitted per kilowatt hour of electricity. 40% of the heat input to the plant is converted to electricity. Okay, now we have to determine the amount of ash per kilowatt hour of electricity. Okay, just now tadi dalam per megajoule of heat input. Now this time around per kilowatt of electricity produced. So we know that the power plant efficiency is 40%, means that if the heat input, if the coal consumed is 100 megajoule, means 40%, only 40 100 megajoule, so only 40 megajoule is being only 40 megajoule electricity produced from the power plant because only 40% of efficiency. So we need to calculate this time around the mass of ash per this electricity production produced. Okay, so first one, just now we have the heat input. We already have the heat input 1.35 something just now. So 40% of that 1.35. So that is the electricity production assume of this power plant, the power production of this power plant. And then from there, only 2% of the ash entering the plant is emitted to the atmosphere. Okay, so the amount of the ash consumed just now, around 40,000 kilogram just now per year, in a year, the amount of ash consumed, only 2% of that amount of the consumption, the amount of ash, only 2% is being emitted to the atmosphere, to the environment. Okay, so tak banyak sangat lah. Sebenarnya 2%. Okay. Okay, so we should start. Okay. So we calculate the amount of electricity first from the efficiency. Just now 40% kan, 0.4. So multiply with the heat input that kita dapat tadi, 1.35 10 we change back to the kilojoule lah, senang sebab kilowatt kan. So we use kilo lah, kita tak guna mega. Change back. So 1.35 10 power of 10 lah. Okay, because we want to use kilojoule. Okay, this one 10.7 10 power of 7 because it is in megajoule. So yang ni kita nak kekalkan dalam kilo sebab nanti nak convert kepada kilowatt hour tu lebih mudah lah, kilo juga. Okay, so 1.35 10 power of 10 kilojoule. Okay, kilojoule per year. So only 40% of this is being converted into electricity of the heat input. So we have 1.4 or 5 sebenarnya. 1.5 10 power of 6 kilowatt hour, and change it into, sebab sini tadi per year. Okay dah, per year. Sekejap, sorry. This one per year dah. So per year. Okay, year. Okay, 1.5 10 power of 6 kilowatt hour per year electricity produced from the power plant. Okay, heat input given is a 1.35 10 power of 10, but only 40% is being converted into electricity, around 1.5 10 power of 6 kilowatt hour per year. And then the mass of the ash emitted to the environment, only 2%, so 2% 0.02, sorry 2% 0.02, 2%. The mass of the ash consumed just now, 40,000 This is the mass of the ash consumed in the coal power plant. Only 2% is being emitted to the environment. Okay, so around 806 kilogram per year emission. This is the emission just now. This is the consumption consumed, okay, in the coal, and this is the emission, 806 kilogram per year. Okay, so determine just now the mass of ash emitted per kilowatt hour of electricity. Okay, so M ash emitted, the emission over the electricity produced, kilowatt hour. Okay, so divide lah. Okay, this one 806 kilogram per year divide by the 1.5 10 power of 6 kilowatt hour per year. So we have a very, very small value, 0.00005 kilogram per kilowatt hour. Okay, per kilowatt hour of the electricity produced by the coal power plant. 0.0004. Or we can also write it in gram because it is too small. 0.54 gram per kilowatt hour of electricity produced. So this means that the power plant, the coal power plant, emits 0.54 gram of ash per kilowatt hour of electricity generated. Okay, so if the electricity generated is 1.5 10 power of 6, so the total ash emitted, the emission of the ash is 0.54 multiply 1.5, etc. Okay, this is per kilowatt hour. Okay, so we want to estimate how much the emission of the gas. Maybe we can also, if you want to continue, you can also calculate. We only calculated just now the ash. Okay, so maybe you can do the same for other composition, other molecules, maybe a carbon, sulfur, nitrogen. Okay, to see how much the amount of the emission of those gas into the environment lah, atmosphere. Okay, with this parameter given, uh, uh, the mass of the consume of the coal, and the efficiency, etc. Okay, any question? Okay, kalau tak ada, bolehlah cuba, you try again by your own self, try dengan yang molekul lain pula. Maybe try dengan sulfur ke, tengok berapa banyak emission dia kan. Sebab yang ni kita buat satu je untuk ash je kan. Boleh try untuk partikel yang lain lah. Okay.
Tapi doktor, kita tak tahu dia punya berapa persen of other particles entering the plant.
Okay, faham. Bolehlah cuba apa ni, just nak tahu dia punya apa tu, compare kan, comparison. Bolehlah estimate dulu 2% ke kan.
Assume ya.
Okay, this one, maximum allowable NOx emission for fossil fuel program. Okay lah, boleh. Okay. Nak sama juga sikit, okay tak apa. The maximum allowable nitrogen oxide emissions for fossil fuel power plants built after 1997 in the United States is specified to be 0.72 gram kilowatt hour or 65 ng nanogram per joule of fuel heat input to the boiler. Okay. So this is the heat input, either one, this one or this one. Okay, the heat input per kilowatt hour or per joule. A natural gas fire power plant consumes 15 kg per second natural gas and produce 375 megawatt of power. Okay, so consumption, the natural gas consumption is the mass flow rate used is 15 kg per second and the production of power is 375 megawatt. It is estimated that the nitrogen oxide emissions from this power plant is 65 nanogram per joule. Okay, as mentioned. The heating value of natural gas is given here 55,000 kilojoule per kilogram. Okay, so this time around the power plants use the heat source. The source of the power plant is the natural gas. So this natural gas will emit nitrogen oxide. Okay, so determine the overall plant efficiency. Okay, so we know that the value of power produced, you determine the equivalent of NOx. Okay, so we can start with we have this mass flow rate and the heating value. So we can estimate first the total heat input, of the natural gas. Okay, Okay, so total heat input like just now sama juga. But this time around we use natural gas. So natural gas and the heating value of the natural gas. Okay, so natural gas 15 kilogram per second. Heating value 55,000. 55,000 kilojoule per kilogram. Okay, so we'll have the amount of heat input in kilojoule per second or kilowatt. Around 825,000 kilowatt or 825 megawatt. Kilowatt. Okay. We want to calculate overall plant efficiency. So we calculate the heat input first, and then okay, and then we have just now we have the power produced, the electricity produced 375 megawatt. So so the efficiency, the overall efficiency of the power plant using natural gas is the electrical produced 375 megawatt over the QE input. Okay. So 375 divided by 825. So we have around 45%, 45.4%. Okay, so that is the overall plant efficiency, and then determine the equivalent nitrogen oxide emissions in terms of gram per kilowatt hour. Okay, gram per kilowatt hour of electricity produced. Okay, the nitrogen oxide emissions. So we know the efficiency, the plant efficiency. So this time, it is estimated that the nitrogen oxide emissions from this power plant is 65 nanogram per joule. Okay, so nano 10 power minus 9. Okay, so NOx emission $65 here it is given in nanogram per joule. Okay, so nanogram per joule 10 power of minus 9. Change it into joule lah, gram per joule. Okay, this one. The estimation of nitrogen oxide emission from this power plant, and then we know that per electricity per kilowatt hour of electricity. Okay, so we know that the efficiency is 0.45. Okay, 0.45%. Okay. Joule electricity. Okay. Okay, only 0.454 joule the efficiency. Okay, and then to change because this is in gram per joule. Okay, we want to estimate per kilowatt hour electricity. So to change from joule to kilowatt hour electricity, we need to divide, okay, to convert joule to kilowatt hour. We can have direct calculation, just divide it by 3.6 10 power of 6. So ni sebab power 3.6 10 power of 6. Okay, to change the joule to kilowatt hour. Okay, so that multiply with 3.6 10 power of 6. So we have, okay, this one, okay, we have a 0.5 gram per kilowatt hour. Tu dah. Okay, 0.5 gram kilowatt hour. Okay, the equivalent NOx nitrogen oxide emissions in terms of gram per kilowatt hour. Okay, emission of this nitrogen per kilowatt hour of electricity produced. Just now, remember for example 1, we calculated for the C, the amount of ash estimated emitted per kilowatt hour of electricity, right? Okay, so this time the amount of nitrogen oxide emissions is estimated around 65 nanogram, but this is per joule. So we change it into calculate in terms of per kilowatt hour of electricity produced. Okay, so sama je sebenarnya macam yang ni, dia dah bagi in terms of percentage estimation of ash, and then kita calculate per kilowatt hour of electricity produced by the power plant. So this time dia bagi estimation in terms of mass per joule. So we just change it into electricity lah, per kilowatt hour of electricity tu how much NOx emission. So around 0.5 gram kilowatt hour. Kalau if you compare just now yang this one 0.54 gram kilowatt hour, so tak nak samalah. Okay, last one, and not last one, okay, but C, if the plant operates 8,000 hour in a year, determine the amount of emissions, nitrogen oxide emissions per year. Okay, so just convert the amount of value throughout the year. Okay, just now we have the amount, if the plant the amount of NOx emissions per year. Okay, so emissions, we have this emission in terms of heat input kan, heat input there. So we need to know the amount of heat input setahun tu. Okay, depends on the operating hours tu. So Q in just now we have 825 megawatt or 825,000 kilowatt. Kan, this is the heat input. This is the heat input. So it is estimated that the annual operating hours is 8,000 jam. Okay. So this is kilojoule per second, kilowatt, kilojoule per second. So multiply with 8,000. So yang 800 tu, multiply with the 8,000 hour per year. Okay, per year the power plant is running throughout 8,000 hours, 8,000 jam satu tahun. But so we have to change it, 8,000 jam tu equivalent to how many seconds? Okay, seconds, 3,600 seconds. So the total Q heat input of annually in a year, 2.38 10 power of 13 banyak kilojoule per year. Okay, so this is the amount that we have calculated earlier in kilowatt. So kilowatt means kilojoule per second. So this is kilojoule per second. And the power plant is operating at 8,000 hour per year. So this one is to change from hour, change it into seconds. So multiply with 3,600. So we have the total amount of heat input of the natural gas, 2.38 10 power of 13 kilojoule per year. Okay. Now, to estimate the amount of nitrogen oxide emissions per year. Okay, the emission just now, emission per year is given as 65 nano. 65 nano just now, 65 10 power of 9, minus 9 gram per joule. I mean per heat input, 65 nanogram of nitrogen oxide is being emitted. Okay, so that is for per heat input. Now we have 2.38 10 power of 13 heat input. So multiply with this number 2.38 Okay, the total heat input for a year. Okay, so this one is in gram per joule. This one is in kilojoule. Per year. Okay. So we have the answer in kilogram per year. Kilogram per year. Okay, actually you can change this one from gram to kilogram, but actually it can because if you change this from gram to kilogram, and then we have to change back this one joule to kilojoule. So actually darab 1,000 bagi 1,000 balik. So kalau tak darab, tak change pun tak apa. And so your answer will still be in kilojoule. You can change it into kilogram per year. Okay, so the amount of nitrogen oxide emissions per year is 1.54 10 power of 6 or in tons. Kilogram per year setahun so banyak juga lah. So therefore this natural gas power plant is responsible for 1,540 tons of nitrogen oxide emissions to the environment per year. Okay, kalau tulis dalam tan kan, tons, 1,000 kilogram equals to 1 tons per year. emission of nitrogen oxide. Okay, because the running hours lagi banyak lah. Ni kat sini 8,000 hours per year. Okay. Okay, this one lain sikit. A bit different because we need to use chemical reaction equation. Okay, because we have air fuel ratio here. So a diesel engine operates on an average air fuel ratio of 18 kilogram air per kilogram fuel. The engine use light diesel fuel that contains 750 ppm of sulfur by mass. Assume that all of this sulfur is converted to sulfur dioxide in the combustion chamber, and all of the sulfur dioxide produced is converted to sulfurous acid, which is the chemical compound is H2SO3 in the atmosphere. If the rate of the air entering the engine is 336 kilogram per hour, determine the mass flow rate of this sulfurous acid added to the environment. Okay, so this time not tak panjang sangat macam tadi, tapi kita guna chemical reaction sikit, process. So if you recall back, air fuel ratio is the ratio of the mass of air per mass of fuel. So berat air tu air pula, udara, air per fuel. Okay, the ratio given is 18. And we know that the mass of air is 336. So from there, this one kan, ni ratio yang diberi 18, and kita tahu rate mass flow rate of air is 336. So we can, from here, we can use this ratio. Okay, to get the mass of the fuel. Okay, the diesel fuel tu. Okay. So M fuel from the yang ni air. Okay. Air fuel ratio tu. Okay, air fuel ratio tu 18. The mass flow rate tu 336. Okay, 336 mass flow rate. Air fuel 18. So we have the mass flow rate of the fuel. Okay, dapatlah kat sini. Okay, and then sulfur. So sulfur is one part, composition of the diesel. So dalam diesel tu ada sulfur, ada campur-campur bahan lain, tapi some part adalah sulfur. Okay. So the sulfur contains the diesel contains 750 ppm. ppm ni 10 power of -6. So the mass flow rate of sulfur in the diesel engine, the fuel, 750. Okay. From this one, this is 18.67 kilogram per hour, because this one is in kilogram per hour. So multiply dengan 18.67. So the portion of the sulfur in the diesel, the fuel diesel, is 0.0 0.014 kilogram per hour. So only 0.014 contains from the diesel contains sulfur, containing sulfur. Okay. Determine the mass flow rate of sulfurous acid added to the environment. Okay, so here where we have to use the chemical reaction. Okay, first we have this sulfur. Okay, so sulfur is the chemical S. Okay, so sulfur plus oxygen, we get the sulfur dioxide kan. Okay, sulfur dioxide. Okay, assume that all of this sulfur is converted to, mention here, assume that all of this sulfur, the 750 sulfur, is converted to SO2. So means that total complete complete process, complete chemical process in the combustion chamber. Okay, all of the sulfur is being converted to sulfur dioxide, and all of the sulfur dioxide produced is converted to sulfurous acid. Okay, so from this chemical reaction, we know that the ratio one sulfur produce one SO2 sulfur dioxide. Okay, so satu di sebelah satu je lah, tak perlu multiply dengan apa-apa. So we can calculate directly the mass of the sulfur dioxide tu. Okay, the mass of the sulfur dioxide from the sulfur, the mass of the sulfur that we know here, but we have to use molar number lah, the molar. Okay, ni if you recall back your the chemistry, a bit of the chemistry, tapi tak susah, just sikit je chemistry. Ratio, because this is like 1-to-1 ratio. Okay, 1:1 ratio, so direct. So the ratio of the mass of the sulfur dioxide to the mass of the sulfur is equal to the mass, the molar mass, molar mass of the sulfur dioxide over the molar mass of the sulfur. Okay, the ratio, 1-to-1 ratio. Okay, so this one is 0.014, and this one, okay, total of the molar mass of sulfur dioxide is 64 kilogram per kilomole. This one boleh search je lah chemical compound ni kan, macam kalau oksigen tu 16 kan, 16, so O2, so jadilah 32 macam tu lah kan. Okay, so M sulfur 32. Okay, so this is the molar mass of sulfur dioxide, and this is the molar mass of sulfur. Okay, so divide this and multiply with the M sulfur, so we have around 0.028. Tak muat 0.028 kilogram per hour. Okay, so means that from the mass of the sulfur here, we can calculate the mass of the sulfur dioxide. Okay, but not finished yet. Another reaction. Okay, so assume that all of the sulfur is converted to SO2, and all of this SO2 is converted to sulfurous acid. So another chemical reaction. But luckily it is complete. So 1-to-1 ratio to produce the sulfurous acid. Sulfurous acid just now, okay, sulfurous acid ni H2SO3 kan. Means that somehow we use all of the sulfur dioxide is converted to H2SO3. So from here nak guna apa kan, what is the chemical compound, okay, to produce sulfurous acid from the sulfur dioxide. So kita tengok sini, we have hydrogen and we need extra oxygen kan. So obviously it is water, H2O. Okay, H2O kan. Sebab nak dapatkan ni mesti dia apa, hujan asid tadi tu kan. Acid rain tu mesti dia ada water lah, hydrogen. Okay, so again complete combustion 1:1 ratio. So easier for us to calculate. So the same method to estimate the amount of the sulfuric acid. Same lah, molar mass of this sulfuric acid H2SO3 over the molar mass of sulfur dioxide just now. Sulfur dioxide. Okay, so this one nanti cari dia punya molar mass dalam around 82, and this one 64 just now. Okay, so you multiply with the 0.028 ni, same method, sama je method dia. So 0.036 kilogram per hour. Okay, kejap kita bagi laluan azan kejap tapi belum break Okay. So this is the final answer. Okay. So because we want to determine the mass flow rate of sulfurous acid added to the environment. So means that we have the diesel engine. The diesel engines operates at air fuel ratio 18. Okay, is produce 0.036 kilogram per hour of sulfurous acid to the environment, added to the environment. Okay. Okay, so the amount of the sulfurous acid produced depends on the amount of the sulfur containing in the diesel fuel. So if the diesel engine contain less sulfur by mass, okay, if the diesel have less, if we can produce a diesel engine that have less sulfur containing inside, so means that less emission of sulfurous acid is added to the environment, to the atmosphere. Okay, so that's how we estimate the amount of the sulfur in the environment. Okay, I think that's all. This last example is actually just calculate in the household, estimate the use of the electricity, the amount of carbon dioxide emission in the household. Okay, due to the use of the electricity in the household. Okay, you can try to do that lah. Yang ni simple je, tak ada guna chemical reaction apa-apa lah. Okay, so that's all. From me for this chapter. So we tak continue lah lepas ini habis, tak ada lepas break dah lah. Okay, kalau tak ada apa-apa soalan, ada apa-apa any questions? Okay, kalau tak ada apa-apa, saya stop sharing. Stop recording.